Hello guys and welcome back to our YouTube channel. So in this video we're going to go through the Northwest Regional Mock 2024 question, and this is the question. I think it was question 5 if I've not forgotten, and I did it in class with my students and I just snapped them out to come and explain here for us, for other students under the African Center of Excellence Forum. Okay, now let us begin the question. The question says a simple potentiometer circuit is set up as shown below using a uniform wire PQ of length 100 centimeter which has a resistance of 4.0 ohms. The resistance of the battery 9.0 volt is negligible. Sorry for my handwriting. The blackboard was even not that good. Okay, this is the circuit here we are having. The circuit is 9.0 volt and the internal resistance is negligible. We have the resistance array, which is a rheostat, I think, just from the symbol. Then we have PQ is a length, is a wire, but they have just divided it at N here and they have just put there a galvanometer, and they're saying that the voltage drop from P to N is 1.5 volt. That is that they have indicated there. Now they're saying that if R were given a value of 3.2 ohms, what will be the length of Pn for zero galvanometer deflection? B. If always read the question or as usual. If R is now replaced by 2.0 ohms and the 1.5 volt cell and the galvanometer were replaced by a voltmeter of resistance 25 ohms, what will be the reading of the voltmeter if the contact at N were placed at the midpoint of PQ? Question mark. State one major difference between a potentiometer and a voltmeter. Yeah, that is that for the question. So let us now see how to begin with the question. We have been given that the internal cell is negligible. We have been given PQ to be what? 100 centimeters, and we don't know. We are determining the length Pn, and we know that there is a relationship between voltage and length. But the problem now is, what is the relationship? So I derived the relationship. So this is the relationship. We know that from Ohm's law, this is what they have given to us, that PQ is 100 centimeters, Pn is question mark, RPQ is 4.0 ohms, RPN is question mark. We don't know the resistance of RPN. And we have been given the voltage VPN is 1.5 volt, and VPQ is another question mark, we don't know it. Well, you know that from Ohm's law, V is directly proportional to I, which implies V equals to Ri, where R is the constant of proportionality. That is, if you remove the proportionality symbol, you have to put the proportionality constant each time you have a something like that. Now, experimentally, R equals to rho L on A, right? Where rho is the electrical resistivity in ohm per meter, ohm meter. Then L is the length of the conductor or the material in question, and A is the surface area of the material in question. If you take this R and you replace it up there, you'll be having V equals to rho L on A, all that I am talking about here, all that I here. If you take this arrow here and you replace it here, you just get this relationship. Now V equals to rho I on A and then L. Now you see that rho is a constant, it depends on the material. And if here we are having that it is being connected in series, it means the current through all the points, the current at P, at N, at Q, and any point have to be the same, right? Now the current have to be the same. Sorry, my pointer. So the current have to be what? The same, right? Now, if that current is the same, because they are telling us that we should find at zero galvanometer deflection. Zero galvanometer deflection means that there is no current at this down junction like this. There is no current flowing in this direction when there is no deflection, at zero deflection. So we know that all the current leaving the battery will just come down like this and go like this back to the circuit, and that is that. Well, we just now have to use that relationship. From that relationship, we now see that V is directly proportional to L, since rho is a constant, I is the current uniform through the wire, a uniform wire, the question said, and the surface area is also uniform, since the wire have a uniform density, or it is a uniform set of material. Now, all of this remains a constant, so V is directly proportional to L from this relationship from here. So we now see that V will be equals to KL, removing the proportionality symbol as well. I just call now this one K, since I call the other one of them to be R. I call this one now K. Well, now if this, you can now say V over L equals to K, which implies V1 over L1 equals to V2 on L2, right? Now you can now see that We have a good relationship here. Now this relationship where rho is that you can post the division of it, that is where I define those variables. Now if you come to get now the voltage across the PQ, if you know the voltage and we know the length, we can just now determine, and we know the voltage, we can just use our relationship with their length and the voltage, and we can determine the length. So that is why I just said that let me use Kirchoff's voltage law or loop rule, KVL, to apply it in this loop, in the first loop like this. So applying that Kirchoff's loop rule, we see that we have our 9-volt battery here. The source EMF is 9 volts. So removing from the knowing value, I will traverse the loop in this direction. So we now see that we have the positive E for the 9-volt battery, then minus IRPQ. That is, this is just like taking it just to be a resistor. That one is flowing through it as I uniform resistor. So we have this to be IRPQ, which is the current leaving the battery, and that is, and we go now this one, we encounter a resistor, a rheostat, a resistor which has a value of 3.2 ohms at that time. So we have 3.2 and IR, where R is the what, the resistance. It is minus since we are going in the same direction as the current flow, in the same direction as we are traversing the loop, and that's equals 0. So we now get E equals to IRPQ plus IR. I just transported all of these terms together. Now we just simply now factor out I here, I into RPQ plus R equals to E, and then we divide both sides by this quantity, and then I will be just E on all of this quantity, and you see it here on my left. So you see here we have it. So you see here we are having it. So this is it here. We are having I V equals to that on our right. We are having that quantity on our right, and you now see 9.0 volt divided by 4.0 ohms plus 3.2 ohms. We now get 1.25 ampere. That is the current leaving the battery. And now to know the voltage drop, that is the voltage across PQ, we'll now use our Ohm's law. Hence VPQ will be equals to IRPQ, using voltage V equals to RI. In fact, if it's this type of circuit, always know Ohm's law, right? So we now 1.25 times 4. We have a video for Ohm's law, you can check and wish. So 1.25 times 4.0 ohms, we get 5 volts. So that is the voltage drop across PQ. Now we can go ahead, we know that VPQ is equals to KLP, and same scenario here. So we now get our V1 to be equals to 500 volt, our L1 to be equals to 100 centimeters. Now our V2 will be equals to 1.5 volt, the voltage of that our length PN, and now our length L2 will be equals to question mark. That is what we are going to find. So you now make it the subject, you will now get L1 on, you just get this same relationship and you replace it here, and you see neatly how 5 volt V1 over V2 equals to L1 over L2, and we just get in that relationship, and you just cross multiply and get our L to be 30 centimeters, which is correct since it is no longer than the wire, I think. So that is the voltage. Now for the B part, I'm running out of time. I'm against time. So for the B part, they're saying that if arrow is now replaced by 2.0 ohms and the 1.5 volt cell and galvanometer will replaced by a voltmeter of resistance 25 ohms, where would be the reading? What would be the reading of the voltmeter if the contact at N were placed at the midpoint of PQ? Wow. So now we have placed it at midpoint of PQ. Then it means we have placed it at a distance of what? 50 centimeters PQ here. It will be 50 centimeters. It was already 100 centimeters long. Now if we place it here, we have replaced our arrow is now having 2.0 ohms. You can still use the same scenario that we did. So remember, here we have replaced all of this with a voltmeter. And what is a voltmeter? A voltmeter is always connected in parallel since it has a very high resistance compared to all of this. So we have here, even though this 25 I think a voltmeter should be around, it should be really more than 25. Anyway, now a voltmeter just neglect the resistance, right? So we know that all the current flowing here will be very small since it is a voltmeter. So almost all the current will be going in this direction. Now if you still apply your loop rule here, the same thing we did. You know that I is inversely proportional to R. Since the voltmeter has a very high resistance, the current going through it is very small, or in fact it can, if 2 amps is leaving the battery, then the current going through the voltmeter can be 0.000001 ampere. Then the current flowing through the through the battery will now be 2 minus all of this, which will be same as 1.9999999, then maybe something. You see, it's very very small. So that is that for the voltmeter. So we just neglect the resistance of the voltmeter, and we now still apply and we get the same scenario, but now our R here have changed to be 2, not more 3.2. So we now apply it gently and we get the value of our new I. Our new I becomes 1.5 ampere, that is 9 volt on 6 ohms, the equivalent resistance of 4.0 plus 2.0, we get 6 ohms. Now Vpq will now be the new value of the voltage, which will now be 1.5 multiplied by 4.0. I did not, students will slow with calculators. I just say 1.5 is 3 on 2 times 4.0, and the 2 cancels and we get 6 volts. Now since material is always uniform, the voltmeter at half pq will read half Vpq. Exactly, since the material is uniform, it has a uniform the material has a uniform density of cross-sectional area, and then the at n here, so the ratio of the voltage here will be the one that this voltmeter will read, right? Since we have got the voltage the Vpq to be 6 volts, then the voltage Vpn will be simply what, 6 over 2, which will give you 3 volts. Since the material is having a uniform, that is, the resistance here is simply 2 ohms in other words. Anyway, I took an alternative and say that, or Rpq is equals to Rpn plus Rnq. That is, I take the resistance the resistance I took the resistance from P to Q to be 4 ohms. Now the resistance of PQ have to be equal to the resistance from here to here plus the resistance from here to here, right? Since they are in series, the equivalent resistance. Now you know that, and this one they have the same length in separations and the same material and the same cross-sectional area. It means the resistance here and resistance here have to be the same, since resistance R is equal to rho L over A. So since they have the same length, the same material have the same electrical resistivity, the same surface area, and then the resistance have to be the same. So the resistance have to be the same, and I just call it R. Then we now get RPQ will be equals to R plus R, and RPQ equals to 2R. And you can say RPQ will be equals to R on 2, which will be R on 2, which will be 4.0 ohms on 2, which will now be 2.0 ohms. So 2.0 ohms will be the resistance there. Then from, since we got our current to be 1.5 ampere from here, we got the current to be 1.5 ampere, since we now replaced our resistance to be 2.0 ohms. We now substitute everything here, and we now get 1.5 ampere multiplied by the resistance of Rpn, which is 2.0 ohms, and we still get 3 volts. That is the voltage that will be read by our voltmeter, which is connected at halfway between PQ, that is Pn. Okay, that is that for the third. And the second and the last part of the question is simply saying that state one major difference between a potentiometer and a voltmeter. Anyway, 100 centimeter we are having 4 ohms. At 50 centimeter we are having 2 ohms. And if you go to 5 centimeter, you'll be having a different resistance. But for the voltmeter, it has just a fixed resistance. So that is a very big difference. So thanks for